Assalamu alaikum guys, it's me again, and I want to go through these notes again to emphasize on the things that maybe little bit I missed in the previous record, just to make sure that the concepts are all clear for everybody. Since I went through these 5 pages, all of them, now I can again just simply go, and if you recall, I kept saying that these all details, we will come to them later, but let me remind you, since we already went through that 5th page, first of all 4th page, and we realized that we have forces along the y-axis, which are the normal force, and the y component of the force of gravity, and then along the x direction we have the x component of the force of gravity. And if we allow the object to move, and if the surface has friction, so on the x-axis we have the x component of the force of gravity in the direction of motion, and the friction force against the direction of motion. Now we mention a few stuff, and we say that it is easy to understand that, for example, the normal force will never change to be perpendicular to the surface. It's always perpendicular to the surface where the object is locating. So that will never change. And the force of gravity is always down towards the earth, towards the ground. That will never change. Whether it is an inclined plane or whether it is a normal horizontal plane, normal force is always down. Gravitational force is always down. Normal force is always perpendicular to the surface. There is a third always thing that it will never change. It is the friction force. If the problem mentioned that there is a friction force, it will always be against the direction of motion. So wherever the object is moving, the friction force will be against the direction of motion. So we have 3 things that will never change. One of them, gravitational force is always downward. Normal force is always perpendicular to the surface. The third one, friction force is always against the direction of motion. All right? I think I make things better now. Now go back to write those equations of motion. From the point of view, Newton's second law, which is F net. Okay, I was thinking if I will click on markup, it will allow me to write. Just a second, guys. All right, it's allowing me. Good. So, from the point of view of Newton's second law of motion, F net is equal ma. And in this picture here, we have simply a horizontal surface, right? We have simply a horizontal surface. And the object is sitting on rest. So we mentioned this is no motion, object is at rest. Or we say acceleration is equal to 0. But if you see that we have forces acting on this object, and these are 2 forces. One of them is the normal force, and the other one is the force of gravity. Both forces are along the y-axis. We can see that. Both of them are along the y-axis. So, when we say summation of forces, we have no forces along the x-axis. So by summation of forces, we mean all the forces along the y-axis. And of that matter, it's equal to m times the acceleration along the y-axis. But we know that there is no motion, so no acceleration. So summation of the forces along the y-axis will equal to 0. Now, and I explained this here in this equation, that summation of forces will be equal to 0. But what are the forces? We have two vectors or two forces. F sub n vector plus F sub g vector. You know, when we add vectors, it's just addition. Now, because they are in one dimension, which is the y dimension, we say up minus down, if you remember. So it's Fn minus Fg. Fn minus Fg. I mentioned that, I know, in the previous record, but I have to emphasize on that because it's so important. This equation, again, I am back to Newton's second law of motion. This equation, which is Newton's second law of motion. Excuse me, because I am trying to become familiar with the tools. So this equation has two sides from mathematic point of view. You can see that it has a right side and a left side. The main key to solve your problems correctly and understand the motion is to understand that we have two sides of the equation and you have to deal with both of them. One side is MA. One side to add up all forces acting on the object. Here we can see that it is all the forces are Fn and Fg, and they are opposite in signs. One is up, one is down, and it's equal to 0. So Fn is equal to Fg, and we all know that Fg is mg. Again, a common mistake that the students will do here, that they will say Fnet is equal mg. That is wrong. Fnet does not equal mg. Let me see if I can, it will not help me. Anyway, I can do that once I will use my writing pad. So Fn is equal, sorry, Fnet does not equal mg. Fnet is equal ma. What is equal to mg? It is the Fg is equal to mg. Fg is equal to mg. All right? So we should all know that the right side of equation is not mg, it's ma. You will remember what I am saying once you start solving the problem. All right. Now go back to the inclined plane problem. In the inclined plane problem, let me recall that we have here, we are just considering still nothing. We are just analyzing the forces. See here, I put exclamation mark because still we were not considering any kind of movement. The object was just still. It was just there. And we were just to study the normal force, which is along the y-axis, and the gravitational force, which is downward. And the gravitational force, it has the y component and the x component. The y component is the mg cosine theta, and I don't want you to forget that, even though it is y component, but it is mg cosine theta. And here it is mg sine theta, which is the x component. So just I want to remind you with that. And here we are solving basically the summation of the forces along the y-axis, which is equal may, and definitely there will not be any motion along the y-axis. So again, my will equal to 0. Since you see again, this is the answer of the right side of the problem. It's equal to 0, while the summation of f sub y will give me this. All right, which is it's all the forces acting along the y direction, Fn minus mg cosine theta. This equation came easy because the right side is equal to 0. So Fn is equal mg cosine theta. And here when the motion starts, so we have, I am again going through the last slide. So this is actually as a revision for the previous record, but I really do care that you understand. Once you understand these points, it will not be difficult for you to apply it and solve the problems. So now here we have forces along the x-axis, which are the friction force and the x component of the gravitational force. We have forces along the y-axis, the normal force, and the y component of the gravitational force. So, one very important note is the direction of motion. This is also something that you can assume it. It's not like we say Fn is always perpendicular, mg is always downward, friction force is always against the direction of motion. Those will not change ever. But here, that is our assumption, that the object's motion is only, that the direction of motion, whatever is with the direction of motion, it will be positive, and at whatever against the direction of motion, it will be negative. So along the x-axis, we have ma, and the motion is on the x-axis. So max, this is our acceleration. This is our acceleration, which is along the x-axis, okay? And now, we have the forces along the x-axis, mg sine theta minus fk, which is with the direction of motion, minus the forces against the direction of motion. I wrote all here, so it's clear for you. Now, so we say that if the object is allowed to move, so the movement will be along the x-axis, but there will be no movement along the y-axis, okay? So, the summation of the forces along the y-axis are 0, but we have to know what are the forces along the y-axis. It's the normal force minus the y component of the gravitational force, which is up minus down. Now, we have two equations. ma is equal mg sine theta minus fk. And we know that the friction force from the PowerPoint slides that you were supposed to read, it's equal to mu k times Fn. Mu k times Fn. And then here 0 is equal Fn minus mg. Now we are not anymore in a physics problem. We are in a mathematics problem. We have two equations. The maximum number of unknowns that they are allowed to ask us are two unknowns, because we have two equations. So if you see here, these are two equations of motion, but from here we have Fn, which we can get it from the equation number 2. We will come to examples, inshallah, in the next record. Thank you so much, and I hope now this concept is really clear to you, and you can refer to my record anytime you need to. Assalamu alaikum.